When a vehicle brakes, occupants move forward, hopefully restrained by a seatbelt, and all unrestrained objects continue moving forward towards the front of the vehicle. As the brakes clamp on, there is a weight shift towards the front, and this compresses the front suspension and lifts the suspension at the rear. This is known as pitch. Pitch also happens when a vehicle accelerates. Occupants and cargo move rearwards, and the rear suspension compresses as the front suspension lifts. When a vehicle steers left, there is a weight shift to the right, compressing the suspension on the right. This is known as roll. If a dancing Elvis is hung from the center mirror, he swings forward when braking, swings rearwards when accelerating, he swings left when turning right, and right when turning left. He does nothing when the vehicle is moving, but not accelerating, braking, or cornering. At this static point, dancing Elvis is balanced, just like the vehicle. If a vehicle is accelerated to the maximum, braked to the maximum, and cornered to the maximum, Elvis will have an epileptic fit while hanging from the mirror. But the shape he would make while dancing would be circular. This is known as the traction circle or friction circle of the vehicle. Everything inside the traction circle is what your vehicle is capable of. Fit better brakes, tyres or suspension, and the traction circle gets larger as the vehicle can still grip under more acceleration, braking and cornering force. So when you see drivers doing wild moves in ordinary vehicles, they have only a small traction circle. High quality vehicles have larger traction circles. Many sports cars have an on-screen display that shows the G-forces and traction circle in action. Now that you understand this traction circle, I will adjust what I've told you slightly. The plot on the left is real telemetry data from a racing car. You can see that a vehicle can't accelerate as hard as it can brake, so the circle is more egg-shaped. In motorsport, race engineers diagnose this data for driver improvement and for adjusting the settings of the car. So why do you need to know this? Well, firstly, loss of control crashes, slides, skids and spins are all the result of a driver attempting to do something outside of their vehicle's traction circle. And this traction circle can also be referred to as the 100% rule of tyres. Tyres on a vehicle only have 100% of grip available, so drivers need to share this traction between acceleration, braking and cornering. The traction circle shows us this. With 100% braking, with Elvis swung as far forward as possible, no steering is available, as this does not fit within the traction circle, and dancing Elvis cannot swing to this point. So when no steering is applied, you can brake to the maximum or accelerate to the maximum. The tyres have 100% grip available for either braking or accelerating should you wish to. Similarly, when 100% steering is applied, you cannot do any braking or any acceleration. With the steering wheel turned fully, if you press the brake or accelerator, bad things will happen. But the traction circle also shows us when steering a little, lots of braking or lots of acceleration are possible, and when steering a lot, but not to the maximum, a little braking or a little acceleration are possible. Drifting, therefore, is the art of controlling a vehicle near the edge of the traction circle, using, for example, slightly too much acceleration while steering to break traction. But as the car slides, to ease off the power and or adjust the steering to hold it close to a loss of control. Drifting and skidding introduce one more dynamic force on a vehicle. It is called yaw, and it is when the vehicle rotates around an axis or pole sticking up through the roof of the vehicle. Now that you have a basic understanding of pitch, roll, yaw, and the traction circle of a vehicle, let's examine how this helps to advance your driving safety.